Hello students. In this video I'm going to explain about hydraulic turbines and hydraulic pumps. In hydraulic turbines there are three turbines for your syllabus. First one is Pelton wheel, second is Francis turbine, and third one is Kaplan turbine. The Pelton wheel is a tangential flow high head impulse turbine, and please concentrate on the cursor of mouse to understand the working. So from the dam, the water comes through the penstock to the turbine through the nozzle. Okay, and this nozzle is used to convert that potential energy into kinetic energy. And here you can see a needle and hand wheel arrangement to just to control the flow of water into the turbine. In peak hours, we need more power, so more amount of water to strike the turbine. This needle will move away from the nozzle tip, and when there is a less requirement, then it come near to the tip, the nozzle tip. And you can see a Pelton bucket here which is mounted on the rotor, and this shaft is coupled with the generator to generate the power. And this nozzle, it makes a jet of water, and which is striking the bucket. And as the jet of water strikes the Pelton wheel bucket, so that absorbs kinetic energy from the water, and it move in the opposite direction. In this way it will move, and the other uh, Pelton bucket will come and absorb the kinetic energy and move. So in this way continuously there is a rotation of Pelton wheel, and this casing is used to avoid the splashing of water. And once the water strikes the Pelton bucket, the water is just it will go to the tail race, which is connected to the mainstream of the river. And you can see the Pelton bucket design over here. This is double cup shape design because uh, once it strikes, the force is divided equally in both the directions so that there is no jerk. So to avoid jerk, this arrangement is made. If single cup means there may be chances of jerk in the Pelton wheel because of uneven or unbalanced forces. The next one is Francis turbine. You can see here this is the top view and this one is the side view. And the water here, this is the wallet casing with decrease in the volume as it goes towards this side. There is a decrease in the volume just for two purpose. One is to convert that kinetic energy or potential energy of the water into uh, kinetic energy, and second is for a equal distribution of water, because as it enters over here there may be more quantity of water will be moving inside the turbine, and the remaining water will be it is less compared to the water quantity available at the entry. So that's why for equal distribution, this decrease in the volume you can see over here. And Francis turbine is a medium head turbine, and there are it may be mixed flow or radial flow turbine. And you can see this one is a guide blade which is used to convert potential energy of the fluid into kinetic energy. And both guide blades and runner blades are in aerofoil shape, which I explained you in the class, or the importance of the aerofoil shape. The aerofoil means uh, it convert that potential energy to the kinetic energy, and at the same time there is a reactive force will be acting from the other side. So both impulsive and reactive forces will be acting. We can that's called as a reaction turbine. So this is one of the reaction turbine, and water enters through this reaction the uh, guide blade, and where maximum amount of potential energy is converted into kinetic energy. Then it enters to the runner blade, where uh, the kinetic energy of the water is absorbed by the runner blades and it rotates, and this shaft is connected to the generator to generate the power. And this is the side view. You can see this is volute casing. From the volute casing, water enters through the guide blade to the turbine blades, and you can see there is a draft tube at the outlet. So why this is required? The answer is, at the end of the at the outlet of the turbine, very low pressure region is created at this side. So outside temperature is more outside pressure is more than that of the pressure at this region. So you can't expect any flow in this situation. So that's why for the smooth flow they will use this draft tube, which will maintain that low pressure over here for the smooth flow of this. And one more thing is, um, because of very low pressure there is a very high kinetic energy at this side. So just to avoid that very high kinetic energy at the outlet, they use draft tube. Next one is Kaplan turbine. So this one is Kaplan turbine. This is also called as propeller turbine because this shape or the design of the turbine, it looks like a propeller of the ship. So that's why. And here also it works same as that of Francis turbine. The difference is, uh, this is volute casing. From there it enters, and there is a guide blade through which it enters into the runner blade. The thing is here, as it convert all the potential energy into kinetic energy and enters to the propeller blade. Even in the Kaplan turbine, uh, reaction this guide blades and rotor blade both are made up made as a aerofoil structure, and this is also kind of one type of reaction turbine, but this is called as axial flow turbine because water enters axially and leaves axially. So this is a draft tube, same as a Francis turbine, to avoid uh, the high velocity at the outlet and for the smooth flow of water from inlet to outlet. Next, this is about pump. There are two types. One is centrifugal pump and reciprocating pump. In this centrifugal pump, it is normal pump which we use it in our home for pumping water to the overhead tank. So how it works? Here there is a uh, impeller. It's called as impeller. In turbine, we'll call it as blades, but here it's called as a impeller. And one side the delivery pipe, the other side there is a suction pipe, and that's footwall water sump. From the water sump, it will pump the water to the overhead tank. How it works? This impeller will supply the energy, power to the impeller by means of electricity, and that electric energy is converted into mechanical energy here. And once it rotates, it creates a low pressure region, because of which the water is taken into the impeller, and after that, through the casing, it will increase the head. This is opposite to the turbine, where will utilize the head to convert it into kinetic energy. But here, the kinetic energy of the water is converted into head by the opposite design of this one compared to the turbine. And from the sump, the footwall is a one-way wall. Uh, it will just allow the water from the sump in the upward direction, but in the other direction, it will stop the water flow. And yes, from here it is pumped to the overhead tank. Next one is reciprocating pump. Here, the sump is the bottom. This is a discharge, and piston arrangement is there. This is called crank. This whole thing is to convert. This will convert this connecting rod arrangement. It convert rotary motion of the crank shaft to reciprocating motion of the piston. So as it rotates in this way, half of the circle, then there is a one stroke. This is called one stroke. From if piston moves from this end to the other end, then it is called as one stroke. And when it covers half other half of the cycle, it comes back to the original position, that is second stroke, from left to right and right to left. So at that time what is happening here is, in this from the sump, when the piston moves from left to right, this suction wall opens, and delivery wall was closed at that time. So it will just take the water from the sump, and the suction of the water takes place in this volume. In the next half cycle, next stroke, piston will move from right to left. At that time, suction valve will be closed, delivery valve will be open. So whatever water taken inside the volume in the cylinder is pumped to the discharge. So in when the piston is moving from left to right, suction valve is open, discharge valve is closed, so water is taken into the cylinder. And when piston moves from right to left, the suction valve is closed, delivery valve is open, and water is discharged to the overhead tank. So like this it works. So this is about, here I'm working only, I'm just explaining the working of uh, some working concepts of these pumps and turbines.